3G, 4G slide. You know, I always like to do this just to get the story right. You know, 1G came, we learned voice in the early 90s. We have folks here who were deploying networks from that time. Many of us know that amps, the good old amps, many of us remember that. We're from that era. And then all of a sudden, once 2G did something amazing, it made voice and text so cost effective that all of a sudden disruption happened and you did not need your pager anymore, and eventually you started letting go of your telephone at home. So you know, for something to be a killer app, you need to kill something. A killer app is something which kills something else. So then 3G came, and you know what was the first use case of 3G? It came in Europe, and the first use case in Europe, and I think Sprint tried that also, was fixed wireless replacement against DSL.
Right.
And that actually hurt Europe because they brought, in order to be competitive, they had to bring the pricing down to $15 for 10 gigabytes. That was so low that it actually ended up destroying the market for Europe. I was actually sent to Central Europe, my neighboring country, Austria. The ARPU used to be about 40, 45 euro. It went down to 20, 25 euros in a span of 3 years. ARPU is the average revenue per unit subscriber. You know, average they make per subscriber. It total restriction. So 3G fixed wireless wasn't. But then Steve Jobs comes in, 2007, he comes up with the killer app. And actually, by that time, Europe has decided that 3G was a mistake, and you cannot change their mind. They have started to wait for LTE to make further investments. And then Verizon, of course, pushes it, and then 4G comes with the killer app ready, which disrupts multiple things on the consumer side. So the point here is, the curse of the odd G. The 1G was beginning, 2G, the killer app came. 3G was the beginning for the smartphone, but wasn't profitable, according to many operators, except in the US, 3G was profitable, only in the US. Many European operators said 3G was a mistake.
Yeah.
So then 4G had the killer app. So what's the prognosis based on this for 5G? Well, I'm not going to say it's going to be a failure or anything. I'm just going to say the first years will be to develop, figure out what is the killer app of this technology. That you cannot say, because it takes some time. Is it going to be CV2X? Is it going to be AR, VR? That killer app takes mind. Steve Jobs has passed away, so we need another brain of that caliber who knows how to take multiple fields and make it into something so compelling. Where mankind is still waiting, but yes, we as engineers will trudge on and we will say, no, 5G will have a killer. So 5G fixed wireless, again, is what Verizon is positioning it. In this slide, they don't start with they are also doing an SD-WAN on another side. But the point here is that their initial proposition, where Samsung has done an amazing job of speeding things up and putting pressure on Ericsson and Nokia, is they have launched 3-4 cities with 5G, of course. The jury is still out if it's been successful. We cannot argue about that yet. We can only say, yes, it's been a great focus, and yes, the performance is amazing, but is it going to be enough to disrupt cable MSOs who have the capability on their cable plant to go up to a gigabit? Can you, as 5G, do you want to start promising a gigabit to you? You can't do that? No, it's too costly, because you can get to a gig if you have line of sight. If you don't have, and if you have just 3 or 4 things that you obstruct the signal, we have a problem, and we are working on overcoming them. So can 5G disrupt the cable MSO business case? That is why, unlike Verizon, AT&T has a different view. They are saying, no, we can't compete in this. That will be too much. Maybe the thinking has changed over the last 12 months, but yes, they are different. They are reserved. They have never said that the heart of their business case is fixed wireless. They have always said our business case is mobile 5G. The only challenge they have is that, okay, will the consumer want to buy a 5G handset and pay $80 a month for it. Will you? Will you buy a handset with AR, VR capability? Facebook Live in 3D?
Right now I'm getting it most of the things. Why should I go?
So one of the colleagues in the audience said, I'm already getting everything for my $40 a month.
Yeah.
So it's a question mark. Look, this debate is like beating a dead horse. You know, you get the point. So I'm now going to move quickly to my next topic. There are two things that are important about 5G, which are much more important than that business case, because we as engineers are doing something amazing. And that amazing thing has to be recognized. That is, we're not focusing on that. We are changing an architecture of a network which connects 7 billion people in the world today. And that's not easy. You know, the number of fixed subs are still 1 billion, 1.5 billion. The number of mobile subs are 6, 7 billion around the world. And when we say we are changing the architecture, it's got 4x more implications, you know, on mankind than fixed. That's the first thing I want you to remember. So what is this 5G architecture change? Well, the good old 4G architecture, which was again a shift from 3G, which was circuit switched and IP. This is a pure IP architecture. But there was one more thing that had to happen, and that is where 5G comes in. It's the separation of the control and user plane. That is the heart of the 5G architectural change. Step one. So you're saying that all these boxes are the control functions, and the remaining dumb boxes are the user functions. So now I'm going to have my signaling on a different layer and my data on a different layer. This separation of control and signaling is the heart of the changed architecture, plus a few more things. This is happening in conjunction with a massive virtualization and SDN and FV. So in the good old days, so just like you have control and user plane separation, now you are having a hardware and software separation. The hardware used to come tied with a box. Now it's tied to any commodity infrastructure provider. Of course, it's a big battle. We're talking about production environments, managing connectivity of billions of users around the world. You can't do this that quickly. You know, they have huge implications on the security of a country if these architectures start failing. So that's why it's going to take more time than just doing anything in the enterprise, where you're just changing a bunch of software on a bunch of servers. So this change is happening. It takes time, and AT&T is taking time. It's not happening that fast. Similarly, Verizon and all the operators around the world are taking the traditional hardware-software approach where they're buying. This has been a major catastrophe for operators, for vendors like an Ericsson, who used to sell a $10 million MME or a $10 million P gateway, and all of a sudden now you're saying, I'm just going to buy, sell the software for $1 million. Well, oh, what about my hardware? Well, your software has to work. But it's created a new set of problems around how to automate. And this is the skill set where there's tremendous demand. So it's borrowing the concepts from SDN, software-defined networking, which has been around in the data center world, which was driven again by the FANGs, the Facebooks, Amazons, and Googles. Telco is now migrating to this architecture. This is also happening with a 5G rollout. It's already started, but it's not to fruition. It's going to take 3, 4, 5 years. But now what it does is it allows a network operator to start thinking like an Amazon. Remember, what is Amazon doing? It's doing infrastructure as a service, platform as a service, creating APIs, and you do whatever you want to do. Well, networks have not reached the maturity to start exposing APIs yet. They have not. But that is the disruption that is happening. That is where you have to be in terms of understanding. So this is the second thing. So first is control user plane separation. Second is the migration to the hardware-software separation. So now you can start seeing, as you have seen, that the controller has the control logic of our data center. Similarly, 5G, there is a control plane which controls the functions, which again, mobility, signaling is a bit more complicated, but it's still the concept of separating the control from the data and then virtualization, which is the separation of the hardware from the software. These are two things happening at the same time. They take time to do. And then the hardest part of this has always been the radio environment. So on the left you have the traditional proprietary radio, which used to have which still has three layers. The physical layer. By the way, we radio guys, we never have time to take our heads out of the radio layer. There's so much to do there. Every year it's changing, it's evolving. The IP guys just have one Ethernet, which keeps going from 100 to 1 gig to 10 gig. So they have breathing room to start thinking about the border gateway protocol, or the EIGRP protocol, or the OSPF protocol, or what we could do to change this protocol. Meaning, I'm just talking about how much can a human brain consume in terms of knowledge at one go. So the RAN has been so intensive in terms of even that physical layer you see there has got so many aspects to worry about. It's planning, it's link budgeting, it's design, it's measurement systems, it's maintenance systems, coverage, quality.